The NFA1000 and NFA400 are professional multifunction low-frequency broadband EMF meters that measure electric and magnetic fields. They can also be referred to as electric field meters, Tesla meters, or Gauss meters. They are designed to measure the invisible pollutants that radiate from electrical wiring and devices that use power. The NFA1000 measures frequencies between 5 Hz and 1 MHz, and the NFA400 measures frequencies between 5 Hz and 400 kHz. If you don't have a technical background, please know that training will be required to operate these meters correctly and use them to their full potential. The meters are designed specifically for the requirements of building biologists. The NFA1000 allows for three-dimensional, ungrounded, or potential-free total exposure measurements of AC electric fields. The electric system ground is becoming more and more unreliable as a true grounding point. The NFA1000 eliminates the requirement to ground your meter to acquire electric field measurements. It's also a big time saver as it analyzes 3 directions at once. Included with the K5 carrying case is the NFA1000 or NFA400 meter with a rechargeable battery installed, a silicone protective cover, 12-volt and 15-volt AC adapters, a grounding cable, grounding clamp, an AC grounding plug, a body voltage hand probe, a 4 GB high-speed SD memory card including NFASoft, a USB cable, and a 2.5 mm interface cable for data logging, an operating manual, warranty, and certificate of factory calibration. Both meters measure AC magnetic fields in 3 dimensions on the X, Y, and Z axis simultaneously. The NFA1000 can measure AC electric fields in 3 dimensions, and the NFA400 measures AC electric fields in 1 dimension on the Y-axis. The NFA400 and NFA1000 can also measure DC electric and magnetic fields with optional accessories such as the magnetostatic and electrostatic probes. The NFA1000 and NFA400 offer excellent sensitivity down to 0.1 volts per meter for AC electric fields or 1 nanotesla, which is 0.01 milligauss for AC magnetic fields. The maximum field strength they can measure is 1,999 volts per meter and 19,999 nanotesla, or 199.9 milligauss. With the optional DC electrostatic and DC magnetostatic probes, the DC sensitivity is plus and minus 9,999 volts and plus and minus 10 nanotesla to 99.99 microtesla, respectively. In addition to 3D low-frequency measurement, the NFA1000 and NFA400 also provide the ability to measure body voltage in a full range of 1 to 19,999 millivolts. Both meters can display the actual frequency of the highest measured EMF up to 30 kHz with increased tolerance up to 50 kHz. They also display the frequency band of concern with LEDs for easy identification. The included 4 GB SD memory card on the NFA1000 and NFA400 allows for data logging of its own 3D electric and/or magnetic field readings, and the ability to log readings from another device, such as an HF59B RF meter, at the same time. Both meters include a 6- and 9-point data collection mode, as well as an audio recording function with a built-in microphone. The NFA1000 and NFA400 logs 4 channels of data at the same time. In other words, if you are logging 3D AC magnetic fields, the meter will also log single-axis electric field measurements. And using the NFA1000, if you are logging 3D AC electric field measurements, the meter will also log single-axis magnetic field values. If you have an external device, such as an HF59B connected to the AC-DC input, the data from this device will automatically be recorded on the fourth channel. If you choose to log data on the NFA1000 or NFA400, you will need to view it on a PC or Mac. Using a PC, the meter can be connected directly to an available USB port to view data on the included 4GB SD card. However, the meter's USB port is not compatible with a Mac. When using a Mac, the SD card must be removed from the meter and inserted into an SD memory card reader. The software used to look at this data is called NFASoft. Gigahertz Solutions periodically releases updates to this program. Updates for this software can be found on the Safe Living Technologies website. More details about data logging are covered in another video that features the operation of NFASoft. This software is normally used with the NFA series of meters to effectively process your collected data and interpret the results according to building biology guidelines. NFASoft also allows you to configure many of the meter's default functions. The NFA1000 and NFA400 include a programmable auto power off function after a set period of time to conserve battery life. NFASoft is used to change or disable this setting. Both meters have a Geiger counter audible signal with adjustable volume that is proportional to the measured field strength to assist with source detection. When a low battery message appears on the display, recharge the meter by plugging in the included 15-volt AC adapter to the power jack as shown. The display will alternate between showing CHAR and the remaining battery life. Typically, a full charge on a new battery will occur within 12 to 15 hours. With the new battery, the display should indicate at least 1 day and 12 hours of logging time after charging. This will decrease slowly as the battery ages. Leaving the charger connected longer may result in a higher charge. If you see full on the display, it's time to unplug the charger from the meter. Note that an older battery may not reach the indicated full display status, but will still be acceptable to use. The 12-volt AC adapter is only used to power the meter for long-term data collection and measurement. It will not charge the meter. The I/O port is used as an interface to optional accessories such as the DC electrostatic and DC magnetostatic probes. The NFA1000 and NFA400 have an AC and DC input jack that can be used to receive signals from other testing equipment such as an HF59B or HFW59D and other optional accessories. For conventional measurement of AC magnetic fields, simply set all the switches to the up position. Shown here, the mode is set to auto and the signal is set to TRMS. True RMS is the default building biology and industry standard mode that should be used when measuring AC magnetic or electric fields. Set the field type switch to M3D and power the unit on by moving this switch to the top up position. Note the solid green light showing that you are now measuring in milligauss. If you prefer to measure in nanotesla, this can be configured with NFASoft, which is described in our Datalogging and NFASoft video. Note that the LED beside volt per meter flashes green every few seconds to indicate that a one-dimensional electric field measurement would be measured while logging. Also note the status LED is yellow, showing that we are just measuring and not logging data. A green status LED would indicate that logging is enabled, and a red status LED shows that the meter is charging its battery. Note that when logging without a power source, the status LED will turn off after 15 seconds to conserve battery life. Once you are ready to begin measuring, slowly scan an area and follow the direction of the highest field strength. The Geiger counter tone will also increase closer to the source if you have enabled the sound function. Note that the sound function is disabled by default. Now that we have found an area of concern, we can take a closer look at the meter. The X, Y, and Z axis LEDs show which axis contains the strongest measured magnetic field with a red LED. The frequency LEDs show which frequency ranges contain the primary and secondary levels of radiation. In this configuration, the strongest band is shown in red, and the secondary level is shown in yellow. All other bands are green to show the current scanning range of the meter. If the times 1000 LED is solid, the readings on the screen are to be multiplied by 1000. If the levels go off scale and are greater than 199.9 milligauss or 19,999 nanotesla, the meter will flash the times 1000 LED. Electric fields can be measured reference to ground or ungrounded, potential-free. For best electric field results, use the PM5S or PM1. This allows the meter to show a true potential-free reading without distortions from your body. For more advanced information on the grounding procedure and advanced measuring tips for electric fields, please watch our advanced electric field measurement video. To measure total exposure of AC electric fields in its designed potential-free operation, set the field type switch to E3D. Note the solid green light showing that you are now measuring in volts per meter. Note that the LED beside milligauss flashes green every few seconds to indicate that a one-dimensional magnetic field measurement would be measured while logging. Note once again that the status LED is yellow, showing that we are just measuring and not logging data. Move the meter to the location and area of interest. The Geiger counter tone will also increase closer to the source. Now that we have found the area of concern, we can take a closer look at the meter. This time, the X, Y, and Z axis LEDs show which axis contains the strongest measured electric field with a red LED. And the frequency LEDs show which frequency ranges contain the primary and secondary levels of radiation. If the levels exceed the maximum 1,999 volts per meter, the red times 1000 LED will flash. For more advanced modes of operation and signal analysis, the meter offers many options. While measuring 3D magnetic or 3D electric fields in auto mode, the mode push button, shown here, can be used to quickly change the displayed primary and secondary field measurement between electric and magnetic fields. The primary field is measured by the meter in 3 dimensions, and the secondary field measurement is done on a single axis. For example, if you are measuring 3D magnetic fields in auto mode, pressing the mode push button will toggle the meter to show the measured AC electric field in a single default Y-axis. Or if you are measuring 3D electric fields on the NFA1000 in auto mode, pressing the mode push button will toggle the display to show the measured AC magnetic field in a single default Z-axis. The LEDs shown here always indicate how the meter is measuring. A solid green LED shows the primary measurement, which is in 3 dimensions, and a flashing green LED shows the secondary single-axis measurement. If you would like to measure only a single axis at a time, the meter can be changed to single-axis mode by moving this switch to the X, Y, Z position. Now the meter only shows the measured value of each axis that you choose. These LEDs show which axis is currently selected. This can be changed with each press of the mode push button. If you would like to manually select a single frequency band range to measure, move the mode switch to band as shown. The mode button, shown here, now allows you to select which band or frequency range you would like to measure. Each single push cycles through the bands as follows. The 16 Hz LED, in Europe this frequency, which is actually 16.7 Hz, is used for the AC power supply to many electric trains. This frequency is not used in North America. The 50 or 60 Hz LED, which is the line frequency of household AC power, 50 Hz in Europe, 60 Hz in North America. The 100-120 Hz LED indicates the contribution of the second to fifth even harmonics of 50 or 60 Hz. The 150 or 180 Hz LED indicates the contribution of the third to fifth odd harmonics of 50 to 60 Hz. This LED shows all sources below 2 kHz. And this LED shows all sources above 2 kHz, which are known as dirty electricity. If you would like to know the exact frequency of the highest measured level or dominant frequency, then change the mode switch to frequency as shown. The dominant signal must be at a significant level to use this functionality. The LCD display will then show the frequency in hertz of the strongest signal up to 30 kHz or 50 kHz with increased tolerance. Again, the LED of the corresponding band will be red. The meter is now what's referred to as a frequency counter. To limit the band or frequency range to which you would like to see the actual frequencies, use the mode push button to cycle through the bands as described earlier: 16 Hz, 50 or 60 Hz, 100 or 120 Hz plus harmonics, 150 or 180 Hz plus harmonics, everything below 2 kHz, and everything above 2 kHz. Other operational modes are available through NFASoft. Note that if a band is disabled in the meter's NFASoft configuration settings, the corresponding LED will not illuminate. More details about this will be described in our Datalogging and NFASoft video. Here is an example showing an AC charger radiating mostly at 60 Hz. Back in the default auto mode, the 50 or 60 Hz LED is red, measuring a magnetic field of over 84 milligauss. Here is an example measuring a switching power supply in auto mode. We can quickly see from the LEDs that the primary frequencies of radiation are in the 150 to 2 kHz range. Notice also that the secondary frequencies extend beyond 2 kHz. Here is an example of a switching power supply in frequency mode. In this case, we have set the meter to display 3D magnetic fields over 2 kHz. The display is showing a frequency of just under 26,000 Hz, that is 25.86, multiplied by 1,000 as indicated by this red LED. To change the volume level of the Geiger sound clicks, move the mode switch into its lowest position as shown. Simply use the mode and record buttons as shown to increase or decrease the volume as desired. When the volume is set to your liking, return the mode switch to its previous position. To measure body voltage, connect the meter using the included 17-foot cable to a ground source such as a water pipe or to an electrical outlet using a grounding plug. More information about grounding techniques is included in our advanced electric field measurement video. Connect the hand probe to the body voltage jack as shown. Switch the mode to body voltage and power the unit on. Firmly hold the hand probe as shown and simply read the measured value in millivolts. For the most accurate measurements, your hand should be somewhat moist. While measuring, the NFA1000 and NFA400 allow you to easily make sound recordings using its built-in microphone. This can be very useful to take notes with details of your measurements. To record sound while measuring, press and hold the voice record button shown here while talking. Note that the meter will only record sound while the record button is pressed. Think of it as a push-to-talk button on a two-way radio. While recording sound, the LEDs act like an audio level meter. Once you have determined the highest readings, compare them to the latest building biology guidelines. Currently, SBM 2008 is the most recent building biology standard. A reasonable goal after mitigation would be to have levels reduced to the slight concern level as shown below. Note that milligauss can easily be converted to nanotesla by multiplying by 100. so 1 milligauss would equal 100 nanotesla. Also note that SBM 2008 includes guidelines for both potential-free and grounded measurements. Be sure you are comparing your measured results to the appropriate guideline. Potential-free is shown here, and grounded is shown here. For more detailed information about the NFA1000 or NFA400 and a list of the many measurement accessories available for these meters, please visit the Safe Living Technologies website at slt.co.